Hi everybody, I'm Shane. I'm sitting right now in the boardroom of our factory in Wexford. So we've got a factory just about a mile and a half north of Wexford town here on the old Gorey Road. So I'll tell you a little bit about us first, and then look, when we were asked to do this, I thought we'd take the approach that we give about 3 online CPDs a week, and we've just taken one. There's one that we give that's maybe it's about an hour and 10 minutes long. So we've stripped it back to we can either cover in 15 minutes, or if you want us to carry on, we've got 2 sections of it ready. So I'll describe that to you as we go along. And we just thought we'd just show you sections of something that we give already, and we give these out to consulting engineers and landscape architects. So here's who we are. First of all, Kent Stainless. We're just approaching 40 years old. We'll be 40 years old in a couple of months now. And we set up in the early 80s as a general steel fabricator. And then we got into stainless steel in the late 1980s. And we were making drainage. That became one of our main products for food and drinks factories here. So Ireland has a huge food and drinks industry already. A lot of the drainage for those factories was being made in abroad, and was always being imported in. And so somebody came to us to switch that for import substitution. And we developed a range. And that coincided, luckily for us, we got lucky a number of times. I'll tell you about that now during the presentation. We got lucky a few times. That was one lucky break for us, because right around that time, all the pharmaceutical companies from America started arriving in Ireland. So all these big American multinationals, when they were expanding outside North America, they seemed to pick either one of 3 clusters. There's about 10 clusters in North America for pharmaceutical production. There seems to be, at that time, have been 3 outside North America, and that was Cork, Puerto Rico, and Singapore. So we modified the designs of our drainage products to suit those pharmaceutical factories in Cork, and that challenged us and led us to, design a whole new range of things, really. And then we started, as we were supplying those factories, with drainage, we also designed things like that would protect the walls, wall guards, tubular bump rails, and bollards, and things like that. Okay, and then later on in the 2000s, that stainless steel drainage inside the factories became streetscape drainage. You wouldn't have seen it much in Ireland. We're seeing a bit more of it now. And the bollards that was protecting the walls became a range of street furniture. So we started off making bollards, but get onto our website now and you'll see it's really dominated by hundreds of street furniture products. But that's how it started off. A couple of bollards inside a factory. Contractors then started asking us for bollards on the street. And then we started making seats and bins and planters and whatever else it is. And then we were making manholes inside the factory, and that became an external streetscape manhole covers range as well. Now, you won't see too many stainless steel manhole covers in Ireland, really. You'll see loads of them in London, but you'll see a load actually in Dublin Airport, Terminal 2. We got some major projects around just coming up to 2010, which was great, because what happened from 08, 09, 10, the financial crash came, the recession hit, and we'd already signed up 2 major projects that took us a couple of years to deliver. And that was the Lewis Light Rail project and Dublin Airport T2. So we got lucky here again. That was our first stroke of luck there, the pharmaceutical factories coming in here. As the recession hit, we had a couple of projects that tided us over for the first couple of years of the recession. And then we got really lucky, and that's going to help us, lead into the topic of today's presentation. But we got approached by a shady middleman, I'd say, who I suppose came to us and presented a project to us in Qatar, and we didn't know what Qatar was at this stage, and we thought it was a bluff for a while. These things happen every now and then, and but we followed through and kept an eye on it, and we priced up the project, and if there was one of everything in the project would be worth about €250,000. So it's kind of a big project. We see them every now and then. We ignored a lot of them because we thought we were bluffing. But we just kept an eye on this one. And then we got a call to come over to Qatar. And we had to figure out where Qatar was. And then around that time as well, Qatar just got awarded the World Cup. So we paid more attention to it then. So we went over to Qatar, and we discovered then that the €250,000 project, we had an Excel spreadsheet with one of everything on it, but we were missing like a column with, we found it in a meeting 2 days into it, that there's 16 of these areas, 2 of these areas, 4 of these areas, and the €250,000 project turned into a €13 million project. So we landed that in late 2010, early 2011, and that just kept us going for 3 years or so. It took us to deliver that 13 million project. And we're going to show you some shots of that in a few minutes and what it made us develop. So we were recruiting people when everybody else was letting them go. I remember we gave a presentation to Engineers Ireland, the London chapter, actually, back around this time. And to be able to say we're down in Wexford and we're recruiting people, this was unheard of at the time because everybody else was letting people go. And we were meeting Engineers Ireland members in London because they had to leave Ireland at the time. Right now it's the opposite. I'm going to show you, what we're trying to do here. We're trying to recruit people, and it's hard to get people at the moment. We invested heavily in a website around this time, and we've also got invested a lot in. We had a subsidiary making wastewater belt presses, so we took over a company around early 2000, and that we grew that around this period as well. Okay, right now, where we're seeing the demand coming from is data centers like that, computer chip manufacturing clients. I don't need to mention who. You probably all know who we're talking about there. And then there seems to be a huge growth coming at us right now in large process waste tanks. Okay, so there's the growth in numbers as we went along. We're just about to hit 200 people. We're kind of at about 181 or 82, I think, at the moment. Okay, so in our engineering department, we got 38 people. Of that 38, 6 are in a fully contained, separated R&D department. Okay, so these were all mixed in with engineering until about 6 years ago. We broke it out, and it's given us great benefit then just to have a dedicated R&D department. Okay, we like to engage, especially more recently, with the third level colleges. We like to maybe take on third year engineering students who need their 6-month work placement, and a lot of them will we'll take on 2 or 3 maybe engineering students from UCD or Trinity or WIT. And then we've discovered 2 nice courses here in Maynooth and in Limerick, both product design courses, which are great. There's more than engineering involved in those, but we're designing products here all the time, and the skills that these guys have is very good. So we take on these third year students, and we like to give them a job offer at the end of their 4th year, and if they'll come back to us. And it has been working like that. I'd say about 8 or 9 have come through that route and joined that group of 38. Okay, we're engaging a bit more now with second level with the schools. We've got a couple of school tours coming up. We want people to start thinking about engineering as a choice for third level, and just explain a bit about what it is. My own kid wants to do engineering now, but 3 months ago he didn't really know what it was, so the CAO forced him to have a look at it. But it's confusing for these 16, 17-year-olds to think of what the difference is between mechanical engineering and civil engineering and process chemical engineering and all that. And then we engage heavily with apprenticeships. We've got apprenticeships for welders and sheet metal workers. So we really would appreciate at the end of this, if you know somebody who's looking around, or if they're just a little bit unhappy where they are, or if they just find the cost of living is too much in Dublin, it's a nicer place to move down to, and much easier way of life down here, I find. And I'm here 18 years. And so just please get them to get in touch with us, recruitment@kentstains.com. I'd say we want about 5 or 6 engineers at the moment. They can be junior engineers. A lot of the work we're doing for the chip manufacturing companies in CAD, but most of our work long term is all going to be SolidWorks. We want SolidWorks engineers. Okay, so but please pass it around if you know anybody. And there's the market sectors we serve. Those factories, the food and drinks factories, and became pharmaceutical factories. But then you'll see stainless steel drainage inside gyms and leisure centers and all that as well. We're in civil landscapes. That's what we're going to talk to you about this part today. We're in the wastewater business as well, and we make things for other companies under their own brand name. We're going to talk to you about a small section of this today. Okay, and then we've got a couple of online certified CPDs. Okay, we give these regularly. Specialized drainage for pharmaceutical factories and labs. We didn't do that today because it's quite a bit specialized. We have one on more general building drainage, and maybe the designs that are done for very, for food factories. And sometimes we tailor that if somebody's working on commercial buildings and swimming pools and things like that. But we've got these are certified, third-party certified CPDs. But today we've picked a section of this CPD to give you. So we give a CPD on public realm enhancing projects. I mean, it goes on. It takes us about an hour and 10 minutes to do it. To cover all the sectors, but we're only going to cover a bit of it there today. Our turnover is split between, almost half it's in Ireland, about almost a third in Britain, a little bit in the EU, but then North America is the one that's grown in the last 3 years. It went from nothing to 10% in the last 3 years. And that's all just to pharmaceutical factories. Okay. The Middle East stuff is all civil landscape, streetscape projects. Okay. A few projects here that we're listing projects here that are relevant to the case studies we're showing you today. We've got a whole different set here when we give a pharmaceutical presentation. More London kicked us off. This is where the Greater London Assembly is, where you'll see Amir Khan, I think his name is, the Lord Mayor, where Boris Johnson used to be when he was Lord Mayor, that Greater London Assembly. We started off doing the drainage and street furniture around there. And then we started off doing bollards around Wembley Stadium, and that just led us to grow. Took us a little while to get it really kick-started. And ventilation grills, which we're going to focus on today. And Lusail City in Qatar is streetscape manholes and ventilation grills, okay? And then a few more here in around King's Cross, okay? And then a whole lot of really big projects in London then. London is the one in streetscape development that pushes us, like the pharmaceutical factories pushed us with our drainage design. London seems to be the center for public realm enhancement almost in the world, I'd say. It seems to be streets ahead of New York, I'd say, it's certainly streets ahead of Ireland, and London's very far ahead of all the other cities in Britain. But, these have all very, very demanding projects. These are past 68. These are anti-terrorist street furniture planters outside an institute in London. These are, we did work on a lot of streetscape stuff is done on the roof terraces now on these skyscrapers in London, Battersea Power Station, a lot of you'll know what's going on there. That was one of the biggest building sites in Europe, really, for the last couple of years. Chelsea Barracks is the one that's keeping us busy right now. Started 2018, but we're still delivering to it now. Okay. Okay, we'll send you on this afterwards. You can look at it, but we've got a very nice project reference list in London. Now, we've got loads in Ireland as well, but these are just the ones that really stand out. Okay. And look, when we give the long presentation, we focus on all these 9 sectors here: manholes, vent grills, in-ground units, which are a beautiful new product for us in the last 7 or 8 years. Drainage, loading, we talk about anti-terrorist street furniture. But today, I just thought, to pick a section to give you an example, we're going to do the vent grills. We'll finish that out. If it looks like we've time, we'll go on and talk about stainless steel grades and finishes and show you some examples of the way it's polished and that. Okay, but we'll see. We'll certainly get this part done, and we might finish off on this if you want to still hear me talking after 20 minutes or so. So ventilation grills. Right. So we saw this problem out on in the market. These are photographs on the Beacon Hospital, the multi-story car park there. There's nothing wrong with these. These are functional. They're fine. This is flow forged grating. It's a lot lower cost than the gratings we're going to describe to you now in a few minutes. But you can see here, you're getting the wheel of the car is probably turning here, churning up the gratings a bit. So as well as the downward force, you're getting that kind of sideward force on it as well. And okay. And then look at the gaps here. Sinead, you mentioned to me, Sinead was going to tell me the diameter of the heels she uses very often, but I certainly think her heels will go down through these here, right? And even kind of fairly flat, not so elaborate, stiletto heels would go through these, but a lot of heels will go through these. And then kind of, look, you see these ugly lockdown points on them. And that's, by the way, it's fine in an underground car park, but this kind of was the standard strong grating that was there to ventilate underground chambers. Now, what we've done is we've come up with Lusail City forced us really to design very strong load bearing. Okay, these are all load bearing, okay, but they're not very pretty. These are on load bearing and heel proof. Okay, so you can see how wide the pedestrian plaza is here. You're going to get MEWPs and some kind of maintenance vehicles traveling along here to deal with these palm trees and whatever else it is. Okay, right, there we go. Some very, very large chambers there. So you can imagine the weak point would be right there in the middle of this. Okay, so if you do the wrong thing here, you can cause a lot of problems. So there's a couple of shots from Lusail City in Qatar. This is what became 13 million that we thought was 250 grand at the start. Okay. Now, when we do these projects, some of the consulting engineers and architects kind of, end the meeting with, can you make sure you're in compliance with all the relevant standards to do with being heel proof? And the truth is, they don't know this, but they're not written very well, the standards. There's not really a standard written about heel proof compliance. So we're going to show you here an extract from the American Disability Act. Okay, so what the Americans say is, when you have an opening on the street no greater than ½ an inch, okay, so ½ an inch is 13 millimeters, okay, they must not be more than 13 millimeters in one direction. And what they say then is that a heel-proof grate, a grate that has openings of 1/4 to 5/16 of an inch, so we're talking 6 to 8 millimeters here, can be considered American Disability Act compliant because the size is opening is less than ½ an inch. So what they're really saying is there's 6 or 8 mil is below 13 mil. So that means, you know, it's compliant with ADA. So really, they're not saying to be heel proof, you need to be this size. They just, they put a sentence in here saying a heel proof is this, but they're not really, haven't really written a standard to say what should be heel proof and what's not. And then in Europe, we have the European norm EN 1433. Okay. And what they say is when you have slots, for example, we make slot drainage. When you have slots opening on the road, when there's that slot is from 8 to 18 millimeters. For example, our slot drain gaps would be about 10 millimeters opening on the street. When you have slot drain and it's below 18 millimeters opening, you don't have to break up that open slot. You can continue it for hundreds of meters if you want. Okay. And what they say is if your gap is between 18 and 25 millimeters, you have to break it up every 170 mil. So if you think of maybe, you know, like where I grew up in Leixlip, there was, you know, in a housing estate, you've got the footpaths from concrete and then you got the road from tarmac. And on the tarmac road, there's those kind of curb drains, the little dished shaped drains, and they'd have a gap of about 25 mil in the hinged cast iron covers. But, you know, you'll see the gaps on those are would never extend more than 170 mil. So they're being in compliance with EN 1433. But you couldn't continue them for hundreds of meters, that big opening, okay? So all they do here again is chuck in a little proviso in pedestrian streets and pedestrian areas. The slot width can be reduced to 5 mil at the specifier's discretion. So not really saying what's heel proof and what's not, but they're just really saying they accept that there's a lot of slots that maybe as far as 5 mil opening, down as far as that. So generally, what you take from that is though that heel proof is between 6 and 10 millimeters. That's what us and our competitors in the industry would take to be heel proof. And, you know, we'd probably consider 6 to be high heel proof and, you know, 10 or 12 to be heel proof. So there's high heel stilettos and we'd make them with a 6 millimeters opening. Okay. So I'm going to show you a couple of examples of these now. So here's what we call a pedestrian heel mesh. And the structure of this is from a series of flat bars. Okay. This is a wedge heel mesh, very popular with landscape architects. They love this. And it's the structure of it is this triangular wedge bar instead of the flat bar structure. And we saw a gap in the market where if you imagine those very large grill openers that we showed you in Qatar there a little while ago, if you made grills like this or this, and they were, you know, a couple of meters wide, the center point of those is going to be quite a weak area. So we saw a gap in the market for something that was aesthetic and pretty, yet still very, very strong and functional. So we invented this product here, the Kent double wedge heel mesh. Okay, so it's got a wedge on top and a wedge on bottom, a double triangle structure, which gives it great strength. Okay, so we can kind of take, you know, on very wide structures, we can take a 44-ton truckload. These things were designed first to kind of go over. We're in the drainage business. A lot of our drains would be 125 or 150 millimeters wide. That's not much of a clear span. So the center point of them would still be pretty strong, you know, but it's still, they're really for pedestrian areas and some MEWPs, okay, with pneumatic tires. But then as our business grew, the heel-proof drain grates became heel-proof ventilation grates, and they started covering much larger structures. You know, like we showed you there from Lusail City in Qatar. And then we needed to do something to strengthen those. Okay, so I'm going to show you if I can share my screen now. Stop share. We're working okay, Brent, is it? Yeah. Am I on? Right. So here's a heel-proof grate that I showed you made from that flat bar structure. Okay. Okay. Now it's got a load of load-bearing bars, 3 of them here, and about whatever, there's about 15 transverse bars here. Okay. And these are 2 millimeter thick bars and are 8 millimeter centers, giving you a 6 millimeter gap. So Sinead, your 7 mil stiletto will be fine there, right? But a lot of architects probably don't like, and this is the lowest cost one I'm going to show you, don't like the kind of this. You look down on it, you see a pattern, a whole grid of rectangles there, you know, even when you kind of hold it to the side or walk around it, at some stage they disappear. So you see lines in one way. Okay. Again, I'm talking to engineers now, not architects, but there's a big crossover in landscape architecture and engineers. So, you know, you can kind of see the load bearing bars disappear one way. It's very slightly, but it's hard to make them disappear. Okay. There's the load bearing bars below. Okay. Whereas with something like a wedge wire structure, so you can see the structure, not a flat bar there anymore. It's a triangular wedge. And you can also see that we've chamfered the top of the load bearing bar there. So it comes to a point. So it really tends to disappear. So we're kind of taking something that's functional and making it more aesthetically pleasing, okay? So you get that nice kind of wide flat bar. And then, you know, from many more angles, you don't see those load bearing bars anymore from many more angles. Look right down on it, you'll see them all right, yeah. But kind of they tend to disappear from many angles, okay? Right. So now we've got something that's kind of a lot more, well, not a lot more, they're both quite nice, but this is kind of more aesthetically pleasing, okay, for a prestigious project, okay? That's what we saw the gap, okay? Right. And then when we get to those large structures where you have a weak point in the center of it, we came up with that a double wedge wire, so a double triangular shape, okay? So you can imagine a triangle on top of a triangle is very strong structure there, okay? Instead of your wedge. Okay. Okay, and then now, so they're the transverse bars and the load bearing bars are going this way. And we'll make those load bearing bars, in this case, they're 3 millimeters thick, but we'll make them 5, 8, 10 mil thick if needs be, okay? Now, they don't disappear as easily, but they disappear somewhat from many angles, okay? Right, so the most aesthetically pleasing one is this one, but on large structures, now this is just one of my, in my right hand, is much more suitable. But you know, we've kind of reached a point between the two of them there where we can produce something very, very strong that gets almost as good as that aesthetically pleasing one. Okay. I'm going to share again. Okay. Is going on? Yeah. Yeah. Okay. Right. So what we're trying to do is get these things to disappear. Okay. So you know, they almost they disappear here. They almost disappear here. They're visible here. Okay. So they're the load bearing bars. Okay. Now, so also the other thing, remember I showed you those ugly, what I thought ugly lockdown points. I mean, on those wide flow forged gratings, there was a lot of space there to hide those lockdown points. I don't know why they didn't do, but anyway, look, the industry standard is to do it like that. And it's a lower cost product. But when you got a prestigious project, we can hide them lockdown points in between the bars there and keep an Allen head fixing inside in a cage so it won't fall out. Okay. Okay. So then you can have a run of drainage here. Here's a 150 mil wide drainage, the pedestrian heel mesh. Okay. The lower cost one at the start I showed you. Okay. Running along there and no visible lockdown points in it. Okay. So that's Como Plaza in Birmingham, Heelproof, 6 mil gaps. Okay, there it is in Dublin Airport T2 on the air bridge, taking you out from the airport out to the car park. What's interesting now, I've pointed this out to you, you'll start noticing these when you use the airport. But then when you go to T1 and look at what was done all those years ago, it's quite ugly. You probably would have never noticed it before, but I suppose Dublin Airport T2 was a gilt-edged project at the time. It was quite a fine project when it was being designed. So, and this is fine here on a 250 mil wide area that's restricted to pedestrian activity. Okay. Now, here's where it can go wrong. I think I said this to Sinead. This is what people love to see when things go wrong. This is kind of what sticks out in your mind from a presentation. Here, now we haven't done this one. This is a job where we did phase 1 and 2 of the project on Hermitage Street in Paddington. But when it came to phase 3, you know, the contractor wanted to rip cost out of the project. And this is one way of ripping cost out of it. Switch back to, now these are Heelproof grates. They're made from galvanized steel with visible lockdown points in it, but they're the weaker, they're the 2 mil bar grates. And because he's done that, he's on a footpath here, a very wide footpath. And you can see here, you know, there's a car here parked, which may, you know, that's such a wide area. It kind of invites the car to park up there occasionally if needs be. So he has put bollards all around that ventilation grill there. And that's just to protect the grill. So he's done a lower cost project. He's put in lower cost grills and put bollards around it. But like, it looks like that forever now. There was no need to do that. We could have put strong grills in there with a beam network underneath it and no need for bollards. So bollards should really be around the perimeter of the footpath if you need them to stop them getting up on the footpath. But so that's visually a lot of landscape architects would not like to see that. Okay, so that's what we're trying to avoid. Now we're really trying to avoid this. Here is a structure. You can see it's a raised structure. Okay, so you can imagine the engineers and architects designing this, and you can imagine they'd be having a discussion about what traffic can go over this. Now, what can drive over it? Nothing can drive over it. It's right. It's above this guy's elbow here, so it's 1.2 or 1.3 above ground, above finished floor level. Okay, so now why did it break? 16 people were killed in this disaster. It's a little bit hard to see it from the photograph, but as you climb down here, there's flat concrete here, but there's an opening here. Follow my cursor. That's an opening shaft, okay? That goes all the way down there. So these people fell down here and were killed, okay? So now what happened? Well, first of all, you can see there's a weak beam network here. There's a beam going from left to right here. There's no evidence, like there's no beam pockets there. There should be a lattice of beams along here, okay? Where you might have, a whole series of grills that have, there might be 1 meter by 1 meter, all supported by beams with one majorly strong beam going across here from left to right, then a series of smaller beams going up here from top to bottom, okay? Now, why did it happen? Also because nothing can drive here, okay? But it's a raised area, but not raised high enough to prevent people climbing on it. And this is like a plaza area. And there was a concert going on here. So there was an entertainment going on in the plaza. There was about 30 kids up here jumping up and down. So this was a concentrated pedestrian load. So no vehicle got on here, but the pedestrians were up here, up and down, jumping up and down, messing as teenagers would do with music. And that's it. They fell through the structure down through the shaft, and 16 were killed in it, okay? Now, here's a project done right. Here's the wedge wire. So I'm going to show you, they're the kind of the pedestrian type grills, the pedestrian with a flat bar structure, okay? Here's a wedge wire grill. You can see those load bearing bars that are going to left to right. You can't see them at all, okay? And we can curve these. We actually did, our business, we did all the bollards around this project as well. It's one of the railway stations on the Metro of Doha, okay? Okay, so there it is, that wedge wire, it's aesthetically, it's probably the best we have, but it's only good for those 150 mil wide openings. There it is again around another Metro station there, okay? So you can kind of just about see the load bearing bars going across there, but they do tend to disappear, okay? And then what that wedge wire structure, when it's put in the wrong place, this is an error, as you can tell by the lockdown points. We don't do lockdown points like that, but we were, invited over to a project where things had gone wrong in Regent's Place in London, and so we could see kind of areas there. The grills were buckling, and we looked at it, and we just say, the wrong product was in the wrong place here. Fine for pure pedestrian activity, but occasionally there'll be somebody on dealing with those plants and putting some equipment on these grills. Okay. That's what that looks like now. When we arrived, it looked like that. When we left, it looked like this. Okay. So this is what Regent's Place looks like today. It's being changed again now soon. But a whole series of, I think there are 800 by 800 grills supported by a beam network. There's an underground car park below here. Okay. And then kind of a nice seated area here, granite stone. This is actually nicknamed the Giant's Causeway, mimicking the Giant's Causeway up in Antrim. Okay, so that's down at the bottom of Regent's Place. There's a tower just there where the Starbucks and Pret a Manger is. Okay, and then look at this opening here, a massive opening here. We're looking at, this is 30 meters by 8 meters or something like that here. Okay, and we've got a lattice of beams underneath this. Okay, and there's an underground, I think there's an underground car park underneath that as well. Okay. All heel-proof, big area, but that can take traffic loading as well. Now look, our business is as well, we make tree grills, we make balustrade, that's all our balustrade timber top. That seat structure is ours as well. We do all this kind of stuff, but we're just talking today about this section about grills. Okay. And now, how do we make them stronger then? For those, that double wedge structure that I showed you, it has that double triangular structure that's running from left to right, okay? But then we can increase the strength on it by, I showed you the load bearing bars, okay, are running this way from top to bottom here. Okay, so you can see them here, they're at about 50 millimeter centers here. We can bring them into 20 or 25 millimeter centers, so we can double the number of them, okay? And then we can also, I can't show you in this image here, but we can increase the thickness of them. We can go from 5 to 8 to 10 mil thick. So one of the things where these, when we get the inquiries in, how it starts out is, an architect or an engineer is telling us they've got an underground chamber and they're trying to ventilate a chamber, and they need a certain airflow, and they need then a certain free area. So as you increase the number of bars and the thickness of bars, you're diminishing your free area. If you can imagine, if we have a 5 mil bar with a 5 mil gap here, you've got a 50% free area minus the space taken up by these load bearing bars. So in a lot of cases, you'll have about, maybe on a large structure, you might have 42% free area or something like that. Okay. But by making the bars thicker and putting more of them in, you'll be bringing your free area down below 40%, down to 30 or 37, 38 or 37% maybe. Okay. So another way of dealing with that is, instead of increasing the number of bars and the thickness of them, increase the depth of the bars. These are 25 and 30 mil deep. These are 50 mil deep. We've made these 100 mil deep. So once we make the bars deeper, then we don't have to go as thick and put as many of them in. So if you've got a project where you're trying to get, you're at like 50% free area and you're trying not to diminish that too much below 45% free area, the way we do it then is deepen the bars. You've got a deeper grill then. Okay, so you've got to, got to be able to deal with that with your angle frame all around supporting it, but we're strengthening it without impinging on the free area or the reducing the airflow through it. Okay, and when you do it right, you can get all the wheels of a heavy goods vehicle on the whole in the central span of grills. There's a run of grills that's about 16 meters long by about 4 meters wide, and we've got a beam network going across there. Okay, so that's around the corner from the Giant's Causeway. That's on a road leading up there. I'm going to show you what that looks like today. That's just being, this year, that whole area, they're keeping the grills in place, but they're doing up the area right beside it. Okay, it's going to look like this now. Well, it does look like this now. So that truck was going over these grills a few minutes ago. Okay, but now they've installed these, and we manufacture these, part of a presentation. These are Core 10 steel structures. There's illuminations in them, there's perforations in the side, they light up at night. Core 10 steel clad in Kumaru timber with oil. Okay, so that's the same street. Okay, so we did this 11 years ago. Now we've done this year. Okay, and the Giant's Causeway part that I told you about is just, you see where the guy's standing there, it's that area just down there behind that glass area. Okay. Okay, and then if the project allows it, if you've got the money in the job and it's a prestigious job and you want it to look fancy, we can play around with the load-bearing bars and the crossbars, and then we can kind of create something like a chessboard effect or create some kind of pattern. So that's kind of nice. That's at the bottom of a project called Shell Tower. The petroleum people, I think, is it? It's Shell, yeah, the company. Shell Tower in South Bank Place in London. Okay, and that'll take the wheels of a 44-ton truck on that. Okay, as well as save your high heels. Actually, one of the reasons they wanted that crisscross pattern, I forgot to say this now, it's a good point, was when you, if you have the opening of a building just here, and if you ran all your transverse bars this way, then a wheelchair entering it would kind of, its wheels might turn on the bars going, all one way. So actually, that's one of the things that got them thinking about this, that, you should be installing your transverse bars perpendicular to the direction of traffic, so that wheels in a wheelchair should cross them in a perpendicular fashion. Now, this also was done for aesthetics, but that's one of the things they wanted to tackle here as well. Okay. Right, the same kind of structure, double wedge, we do it then on, this is quite a narrow span, but we do this because every now and then you might get wheels across. This is a fountain area. We make fountains. We're not a fountain company, but we make the stainless steel elements of fountains for a couple of fountain companies in Britain. Okay. Now, and then getting to the end of this section here now, and then you can tell me if we want to carry on to the other finishes or not, but this is another problem we see, and I've taken a picture here then from the Beacon Hospital in Dublin. And again, my old favorite, the flow forge grating, functional grating. Okay, you can see they have a beam network underneath it here. Okay, and there's a beam network down here. But, you can imagine somebody walking across here, your keys fall out of your pocket, or you just kick a stone in here or a penny or whatever it is or whatever, or throw down a lighted cigarette through it, and it's going to land on your nice Ferrari. All the nice consultants in the Beacon Hospital have their nice Ferraris parked down here somewhere, and so they something like that. So you can design that kind of thing out. Well, one, the Heelproof grills will stop the cigarettes going down, but but they might get wedged in it. But sometimes if you're concerned about that and you don't want this open gratings and you don't want the Heelproof gratings, because dust and little grit can fall down, and even rain. If you didn't want rain getting down, sometimes you might want to move to vertical ventilation instead of horizontal ventilation. Okay, so if you had that problem, you were trying to address it, you had the free area you're trying to ventilate, what we do there is build the ventilation into the vertical wall of a structure. In this case, it's a seat. Okay, and these seats, you know, these can hinge open. They can contain cavities in there that can hold things in them for, you know, for umbrellas, for seats or something like that, you know. So there's a ventilated seat we made in King's Cross. So it's really just taking the ventilation opening, turning it vertical instead of horizontal, and then disguising it through these louvers that then look like a seat. Okay. There's another example of vertical ventilation, and you can see here the free area. You see 85% instead of 50% free area here. Okay, narrow strips of steel with kind of wide openings between them. Okay, so this had 85% free area, and this is in a granite planter. We didn't do the granite planter. The granite planter has been made by somebody else, but we got the drawings of the granite planter and the curved radius that's in it, and then a cut it as we made it. We made an angle frame and vertical louvered grating to fit into that granite planter. That's at St. Helens. Okay, and there's vertical ventilation in built into the vertical wall of these steps. That's a Battersea power station. Okay, so it's kind of a strange little pattern built into there, quite high free area, but the pattern is built into that there because if you look, we didn't do the balustrade nearby, but somebody else did this, and they wanted this theme to continue across in the design. For us, it's just a laser cut pattern. Could be squares or circles or whatever. In this case, it's patterns that match balustrade. There's the balustrade that's nearby. We actually did make these Core 10 steel bike racks as well. And these are ventilated bollards where this was designed for Qatar as well, where there's a lot of manhole chambers below ground, and you know, in the heat, there's a lot of contraction and expansion and reduction of the you know, the air and gas below in the chambers. So they want to ventilate some manhole chambers, but they want to keep those chambers watertight yet ventilated. So how that's done is you've got some ventilation points here, but we can keep it watertight by running a secondary tube that's not ventilated. So let's say this is a 10-inch tube. We've got a 4-inch tube rising up above the top perforation here, and then the airflow comes through the chamber, up through the central tube, the 4-inch tube, okay, out over the top of the 4-inch tube, and then out through the perforations in the 10-inch tube then. Okay, so it's coming up in that fashion there. It creates, you know, a ventilated structure that's still watertight. Okay. Okay. Now, I was going to go on and talk about finishes here. I don't think we will, because we spent quite a bit of time talking about the grills. We might just leave it there. Sinead, what do you think? I think I probably took half an hour there where we thought we might be 20, 25 minutes. So I might just finish it up there. I think that'll make more sense, and we'll see if there's any questions and answers. Sinead, does that sound okay?
Yeah, that's fine. I mean, we do still have a few more minutes. If I mean, we could go on for another 10, 15 if you wanted.
Well, if my voice takes
I think it might be quite interesting.
Right. Okay. So that's ventilation grills. I told you there's 8 sections in this presentation we give. Another section a lot of people ask us about then is stainless steel finishes. Okay. So what happens? Okay. Well, first of all, I have a few new slides in here. We'll just deal with them first. Okay. What's stainless steel? Stainless steel is typically made up of iron, carbon, chromium, and nickel. And typically the chromium is about 18%. Okay. It's not always. Now, a lot of people know of a couple of grades of stainless steel, but there's about 200 grades of stainless steel. Your knives and forks at home are made out of stainless steel. Your sink might be made out of stainless steel. The catalytic converter in your car, I think, is made out of stainless steel, or the exhaust are made out of stainless steel anyway. Okay, so the 200 grades are split into 4 families: duplex, ferritic, martensitic, and austenitic. And the ones we typically use are austenitic. Occasionally we use a duplex, okay? But austenitic is typically what we use. And across the world, 70% of stainless used is austenitic. And then the majority of that 70% is grade 304. You might hear this mentioned 304 and 316 stainless steel. If you add molybdenum, it's hard to pronounce. I used to call it molybdenum, but it's molybdenum. If you add molybdenum to grade 304 stainless steel, you get grade 316 stainless steel. It adds about 20% to the cost of a finished product, but it increases your corrosion resistance. Okay, so why would you want to increase your corrosion resistance? Because if you're working in a pharmaceutical factory, you might have some highly corrosive chemicals. If you work in a Coca-Cola factory, the sugar concentrate is very corrosive on stainless steel. If you are doing things on the streets in London, in the winter, they're terrified of people slipping. And so what do? They put down salt on the streets. Okay, and salt is corrosive against stainless steel. So all of those things would make you move from grade 3 or 4 stainless up to grade 316 stainless steel. Okay, and then you might see in recent years, you'll see the L being attached to 304 or 316, and that's a low carbon. So the industry is moving from 316 to 316L or 304 to 3L. That's better for the environment, and it's a bit easier for us to weld there as well. Okay. And then you might occasionally, very occasionally, you might see titanium added to 316. Okay, so that's when we do that. Very occasionally, we'll use titanium 316Ti. Occasionally, we'll use duplex instead of 304 or 316. But the majority of what we use is 304 indoors. The majority of what we do outdoors is 316. Okay, you use 316 in swimming pools, where if you can smell chlorine, there's chlorine in the air. Even if you're in the changing rooms, you're not by the pool. If you can still smell the chlorine, there's chlorine in the air. Use 316 stainless. The Coca-Cola factories, the salt, a fish factory, you know what I mean? Those kind of places, the seafood places, anywhere there's aggressive chemicals, all the pharmaceutical factories need 316. Okay. I think I've just said this already, so I'll just skip on from this. Okay. 304 and 316 are very typical terms we use, but they're really the American terms. The European terms are these. They're less used by us here and in Britain, but officially that's what we should be calling them. Okay. Now, if you zoom in with a microscope on some stainless steel and it's polished, what I'll do is I will show you this again here now. Hang on, I want to stop sharing. Stop share. There we go. Right. So, if anybody's interested, we can send over a book of these if you're working on a prestigious project. Now I'm going to try and get the light to shine in this a certain way. We buy in the stainless steel and it looks like this. So the underside of our drains and manholes, all that, they'll all look like this. It'll be, after we weld it, we passivate it so you won't see any scorch marks, okay? Then you'll hear the term polished. So you can kind of just should be able to see grain going from side to side here on this piece here, okay? And that's done by like we buy in these belts of polishing belts, like the 3M as the company makes them. There, it's like sanding your wood at home. You might start with a rough grit and you might finish off with a fine grit. The same things happen with stainless steel. You start with a rough grit and finish with a fine grit. Our standard grit is 320 grit. Okay, and if we use 320 grit, let's see, does this? I don't know if that's readable or not, Brendan, is it? No. Okay. No, I don't know if that helps the camera focus or not. Yeah. But anyway, 0.5 RA is what you're trying to achieve. 0.5 roughness average. Okay. And if you do that, you're in compliance with the European norm 10088 for architectural stainless. So you want a 0.5 RA. And that means if you zoom in on that polish, you'll see peaks and troughs, mountains and valleys, and you want them to be as smooth as possible. Okay. You want the grain to make it pleasing looking. Okay. But you want that to be, you know, as smooth as possible, and you should be in compliance with EN 10088. You should have a grit. So if an architect wrote down polished stainless, that's not good enough. You need to get your grade of stainless right, but more importantly than your grade of stainless is your polish of stainless. Okay, so you can have grade 316 stainless, and you could polish it badly, and then you're going to have problems. And I'll show you pictures of those in a second. And then you can see the pen being reflected here. When we buy in the stainless, well, it looks like this. When we put it in an electropolishing tank, it gives it that kind of hazy mirror finish, okay? So no grain, but you kind of get a reflection of it. And that's great for pharmaceutical projects and that, okay? And then, but if you look over here, you just see a shadow of the pen and not a reflection. Okay? Reflection here, shadow here. We've bead blasted the stainless here. So we've fired beads, tiny beads. I can't remember the couple of micrometer diameter of them, and you fire them at the stainless steel, and you give them that kind of mottled finish. And that's good if you had like a planter or a seat and you had a few panels of stainless and they weren't all lined up with each other. They're kind of, you know, some were going across, some were going up at an angle. Then you might want that grain going across and up at an angle. You could bead blast the whole thing and it'll have a uniform finish. And we like to do is we like to get people to accept it. Take the satin finish and then dip it into an electropolishing tank, which removes a slight skin from the stainless steel, much more hygienic and helps the life of the stainless steel. So now we're exceeding the requirements of that European norm, okay? We're going from an RA of 0.5 to about a 0.25 approximately, okay? And with that bead blast, now bead blast isn't really good for stainless steel, okay? But you can hear how rough it is there, okay? But if you electropolish that bead glass, it helps the life of it. It stops the tarnishing, or it helps stop attracting contaminants. A few more finishes here. That's 304 stainless steel, powder coated with a kind of a metallic black finish. Core 10 is very popular. There's a piece of Core 10 steel. It's not stainless, but this is stainless steel coated to make it look like Core 10 steel. Okay. Okay, so this is better than in your office if I hand these things around, but okay. Right. Now let's share again. Okay, so when you get your microscope and look at that kind of polished finish, so an unscrupulous company may polish it and it's going to look fine when it's delivered to site. When you take a microscope, it's going to look like this. Now, so what? Do you care if it looks like this or this or this? Remember I showed you the electropolishing brings down the URA down to about 0.2. It's smoothing out those peaks and troughs, those hills and valleys. 0.5 is what you'll do to be compliant with the European norm, okay? An RA value, a roughness average value of less than 0.5 microns, okay? In compliance with EN 10088. Okay, and this is kind of a test that the British Stainless Steel Association has done, like firing salt water at it for 21 days. Here's what happens to this, and here's what happens to something in between these two. Okay. Okay, and then when we weld the stainless steel, we can leave it untreated, which we never do. We submerge it in a Pickle and Passivation tank, which restores the skin of the stainless steel. Okay, but some people, if you open up a cabinet or something, they may not passivate their welds. They should passivate their welds, okay? They can brush them, they can grind them, but Pickle Passivate is what should be done. This again is that when you spray the salt on it for 21 days, it looks like this. Okay, so when we said there, what we do in our factory is we've got an overhead crane here, and it drops, for example, here's 7 or 8 drains for a pharmaceutical factory being submerged in Pickle and Passivation acid. And we've got a 7-meter long tank. Submerge them in there and you'll passivate all the welds and bring the stainless steel, restore that protective layer that's on the outside of the stainless steel. Okay, so there's a close-up of that 320 grit polish grain going one direction. Here's a close-up of the same thing that then has been dipped in the electropolishing tank. So you see a slight bit of extra reflection on it. And there's the kind of one that's the hazy mirror finish that we kind of like to use in super hygienic applications. Okay. Now, what goes wrong? Here is a bright satin finish. Here's a satin finish that's been dipped in the electropolishing tank. Okay. This is a Dublin Airport T2. If you look at the paving, you can see it's the same project. Okay. Right. So what can go wrong is if you don't polish it properly. I mean, this guy here delivered these the same year that we delivered these. He won the job because he was lower cost than us. Okay, so we didn't get any of the bollards there. Well, we got some actually. You'll notice them because we have them mechanically fixed down just to match these balustrades, and trolley bays. So, but somebody else then won a few other lower cost projects. That's what happens if you have you can kind of even see the roughness of the polish on that stainless steel there. So he complied with what he was asked for. He delivered polished stainless steel. But what he should have done was have satin finished 320 grit polish in compliance with EN 10088. That's the way the specification clause should be written. Okay. Here's another area of Dublin Airport, and you can see how close these two poles are to each other. This is a round pole we made here. We made it to support digital screens made by Daktronics in County Clare. Okay, and there's a box section post made by somebody else to support kind of the bus stops, the static displays. We didn't make these. We won a contract for these. We didn't win the contract for these. Okay, they're a different contract for some reason. Okay, there's a close-up of the box section support. Now, I actually think it might be, I don't know if that's the company that made it or not. It seems to be made in Germany, but okay. But they didn't polish it well. Okay, and then that's tarnishing, and it's really easy to avoid this. It doesn't cost much to avoid it, but you just got to enforce the specification at the start. And there's a close-up of the round tube, okay? All the same. These pictures now are probably 8 years old. I'm sure it's a lot worse there now. And there is a project where we won the project for this balustrade, okay, here, but we lost the contract for this canopy. This canopy really annoyed us to see this coming into the project because, we've got competitors in Ireland. There's some fine companies in Ireland. We have a great manufacturing sector here in Ireland. This was made in Britain, and it was like 2010, 2011. And, the country was crying out for jobs. And the Irish contractor gave that out to a British company. I thought it was awful. We lose jobs. We lose jobs. So that's fine. We were happy with this. This is worth £1 million to us. This was worth about $1 million as well, and we lost it. But you know, we kind of would have been more respectful if they gave it to another Irish company. But anyway, you can see how close these are to each other. Okay, there's a close up now of the canopy. Okay, that's tarnishing away there. There's nothing really wrong with it. It's just aesthetically, it's not that looking that good. Okay, but it should be looking perfect. It should be looking like this, and it can do if you do it right. Okay. And then look, just to show you, we're not just showing you what other people do wrong. Here is our product. This is our balustrade here, and we have a gate on it. And the maintenance people in the airport, they're using a galvanized steel chain to lock the gate. And this is a case of what's called bimetallic corrosion, where you've got two dissimilar metals in contact with each other. Very easily avoidable by just, you know, most of the chains you might have, if any of you have motorbikes or even bikes, you'll have a kind of a plastic wrap around that chain. That'll stop that happening. But in this case, it's touching, the rain helps that accelerate it, and you're creating that kind of corroding effect then between the galvanized steel and the stainless steel. Okay. Here's another wayfinding structure that's there in Dublin Airport T2. So this is great. Some of you can see this when you walk around the airport, where they've got a stainless steel wayfinding totem or lectern or whatever it is, and they've used zinc fixings to fix it. Okay, so it's a real pity because they save themselves 50 pence here or something like that. You know, and that's going to keep on. You've got galvanized steel, zinc touching stainless steel. That's going to keep on corroding and growing over time. So that's a real, you know, the stuff there. It's, I mean, we didn't even know about this job. We didn't tender for it, but you know, to see somebody do it on a prestigious project like that, and they save themselves 50 pence on each structure and do that, it's a shame. We showed you some examples of other kind of 304 stainless powder coated. Here's a kind of a nice one there called a metallic black. It has a texture in it. Okay, it looks like that, and you kind of shine the light on it there. Some architects like that you don't see the fleck in it until the sun shines on it a certain way. And there it is there on some power bollards. Okay, so metallic black body, 304 stainless steel with a machined cap, 304 stainless steel and reflector strip on it. Okay, there's there being used to, we make sleeves for, these are actually anti-terrorist bollards. These will stop a 7.5 ton truck traveling at 40 miles an hour. If they crash into that straight away, that truck will stop dead there outside that building. Thankfully, we don't seem to need too much of it in Ireland, really, but in London, outside of all the top buildings, there's a lot of anti-terrorist stainless steel, anti-terrorist street furniture. Okay, and there's that kind of metallic black again in a suite of things. The power bollards there, bins there to match it, kind of two-tone finished black body and stainless top. And then just the caps of these are made to match these things here, notice boards. They're very like, if you look at the Lewis, they saw the Lewis notice boards and said, look, God, that looks great. Can you just kind of take the Lewis notice boards and coat it to look like the rest of our project? Okay, and then some two-tone bollards. Okay. Now, there we go. That's the end. I'd say we've taken us up to, it must be up to 55 minutes or so, Sinead. We'll finish up there. Okay, so